So the life support systems are a critical technology for keeping the crew alive and healthy on their journey to Mars. And the life support systems we currently have on the International Space Station break down frequently. It requires a lot of astronaut time to repair them, to maintain them. So one of our key focus areas is making life support systems more reliable. We're also trying to close the loop, trying to recycle more of the air and water and solid waste than we do currently. We don't need completely closed loop systems, but the more we can approach that ideal, the more efficient and the fewer logistics we have to bring along from Earth. Radiation protection is another key technology when we're beyond the Earth's magnetosphere, which protects us from galactic cosmic rays. We'll be exposed to high energy particles that could cause cancer or cognitive impairment on long missions. So we're looking in our human research program at some of the physiological effects, and in the Advanced Exploration Systems program, we're looking at developing new detectors to monitor the radiation environment so we understand how to design for these environments. We have sensors currently operating on the surface of Mars, on the Curiosity rover, sensors on the International Space Station. We're instrumenting the Orion spacecraft for the exploration missions as they pass through the radiation belts. So once we understand the effects, then we can model how radiation is transported through the structures of the spacecraft and try to provide shielding. And it turns out the best shielding material is hydrogen. So water has a lot of hydrogen in it. Polyethylene, which is a long-chain hydrocarbon, has a lot of hydrogen in it. So these are various types of shielding materials. We could have a storm shelter where if there's a solar particle event, the astronauts could retreat into this protected area of the spacecraft that was more highly shielded than other areas. But we think that it's a solvable problem in radiation protection. Another big area is logistics. If we have to carry with us all the tools and spare parts we need to cover any contingency, then that's going to be a huge mass of parts that has to be launched from Earth. So we're looking at 3D printing, additive manufacturing in space to make parts on demand. So we launched a 3D printer to the ISS a couple of years ago. It's printed some plastic parts. We're trying to extend that technology to printing metallic parts and eventually printing electronics. So we can greatly reduce the amount of spares and specialized tools we need to carry with us. We just make parts on demand as needed. We're really seeing in-space manufacturing as a key technology because we can probably reduce the inventory of spares by up to 90% or greater.